So these questions, what they're going to do is the wording, I'm going to try and ask the same thing in as many different ways as I can. So when it says find dy dx, that's just another way of saying find the derivative. Bring the number in front. Subtract 1 from the exponent, and we're done. So you can see why when you find a pattern like this that always works, it's much nicer than using the derivative. Now what mathematicians would have to do before they could, it's not just good enough to notice a pattern and say, I assume it always works. Mathematicians would go and take a general equation and prove that it will always work with any x and any exponent. And then once that's proven, then they say, since we've proven it, now we can do this at any time. Just noticing 100 examples that work doesn't mean that everything will work. You'd have to prove it generally for all. What we do in this course is we look at just the results and start to use them. We don't look at the actual proof of why the power rule works all the time. Check your textbook. It might actually be in there, and you can read it on your own and practice those proofs if you'd like. How'd you do? Did you get it before I put it up there? This is a medium level one. Medium level ones often mean you have to do one small step first before you differentiate. So again, another way of asking for the derivative is differentiate. I'm going to write this out first as y equals. And if I choose y equals, I can choose any kind of notation for my derivative. So whatever I'd like, I could use dy dx or y prime. But before I do that, I'm going to take one extra step to move the exponent to the top so that I can apply the power rule. So the power rule only applies when your exponent is to the variable in the numerator. Right? Everybody remember the negative exponent rule where any power in the denominator can be moved to the numerator by making it negative? Now my derivative, bring the negative 8 in front, would now be negative 24. Subtract 1 from the exponent. And we can simplify this. Taking negative 6x to the negative 9. Can you see yourself making the mistake of writing negative 7 instead of negative 9 when you're dealing with negatives, when you're subtracting 1? 2 units from now, we have a unit on integration. Integration is working backwards, so you will make even more mistakes because sometimes you add and sometimes you subtract and you're just trying to keep all of that straight in your head. Gets a little complicated. New notation. Find d dx of 7x to the 4. It's another way of asking the same thing. Find the derivative. So I can write dy dx to say my derivative here. I could write d dx of 7x to the 4 equals, and this is an easy one, as long as you know your 7 times table, you should be fine.